Thank you very much, Philip. I have to repeat the statement that I usually say at these meetings, which is when we had a meeting about non-tuberculous mycobacteria, 10 people was a crowd, and we were thrilled. So we were often talking to each other, and to see this many physicians and this many patients who are really interested in advancing knowledge and understanding and treatment of disease, it's like Philip says, it really touches you. I have an enormous responsibility as being in the laboratory and trying to use the skills of the laboratory both for research studies, but also to help you clinically, to help the clinician to pick the right drugs, to know which drugs to use, what kind of doses you need to use. One of the things that I can hear you saying about what we've talked about here today, well, that's all fine and dandy, but what about my MAC? I mean, and cystic fibrosis is a classic example in that the defect, which is called the CFTR gene, was detected almost 20 years ago? You think it was that long? 1989. And it is yet to translate into anything that will allow us to benefit the patients. Now, that's not necessarily the fault of the gene. It's that we don't have a mechanism yet for changing your genes or adding something to your genes other than steady infusions of enzymes and materials that are not being made. So we didn't have that mechanism, and that's a holdup too. If the only replacement we have is making you chimeric, putting in you a gene that functions, and maybe it'll grow in particular areas. People have looked at viruses or whatever, but that's a very important point to make, and the point about cystic fibrosis is that the foundation, who can get money out of a turnip, if you've ever been to any of their meetings, has done enormously for those patients. They virtually tripled the lifespan of those individuals from around 14 or 15 to the mid-30s and still going. An amazing thing, and a reminder that it's not just a science. I mean, it did have some science, but it was basically done all without the NIH, not Ken's side of the NIH, but money being given to us. I mean, Joe and I will tell you, I've worked my entire career without an NIH grant, and mostly because I never felt that what we were doing, which is translational, trying to answer that question, what makes me better now, was not necessarily what they wanted to hear about. And that's why one of your biggest goals is to help us find monies to think about when you donate to the Cancer Society or other groups. You have a specific disease, think about donating your money to helping with that disease. That's a story we have to take to all our patients. They all donate to a variety of things. It may be the major source that we have to do the work that we do away from the NIH. Ken is blessed that his money comes from your tax dollars. They do terrific work. But guys like Joe and I and Leah, we're doing all these studies without any real money except donations that come from regular people. So, okay. I'm glad this is bluebonnet season in Texas. It is one of the most amazing views you will ever see, is to look out over acres and acres and acres of this wildflower. It's a little fickle depending on the rain and the weather, but when things are just right, it's just amazing. This is some of the goals of the laboratory, and this is just a very limited part but it's going to go into what I'm pretty much going to talk about is discovery of a drug that has potential, what you do to try to show that that drug is worthwhile, and then what you publish to try to make that acceptable both to the clinicians and to the people who determine what sort of susceptibility testing you can do on individual isolates. MAC especially, as Dr. Eisenman told you, because so few drugs have predicted clinical outcome, we don't recommend them being tested because they're misleading to the clinician. They get the report back that it's resistant, say, to ethambutol for MAC. Well, we don't recommend that testing because it does not predict the outcome of that individual patient. We're only really going to do susceptibility testing on drugs that help the clinician know that if he uses this drug, it is a potential advantage to the patient. We look for new and old drugs, and actually what I'm going to talk about a little bit is about old drugs. Screening new drugs. When a new drug comes along, we don't just give it to patients. It generally goes to the laboratory. We test it against isolates of individual NTM that we have available and try to make decisions about whether or not there's potential to go forward beyond that. We clearly want to support clinical trials. I mean, the ongoing trial of ARIKAYCE requires a laboratory that can grow the organisms, do susceptibilities, and that's part of our responsibility as a group working in the lab. Methods for susceptibility, again, as Dr. Eisenman alluded to, the standards that we've used for most organisms have proven inadequate for NTM, something that, an enigma that has bothered us for years and years and years. It works for virtually almost all other organisms, viruses even, when you set them up with drugs, but we've been unable to set up a system, especially for the anti-tuberculous drugs, the ethambutol, rifampin, and streptomycin, provide any prediction at all about how the patient's going to turn out if you give the patient those drugs. And also testing of these old and new drugs to try to help them or help you predict clinical outcome. As there is only one drug which is approved for susceptibility testing of MAC, which is the macrolides, which is Biaxin or Zithromax. One drug. So the rest of it is sort of, well, it's worked before, it should work again, and that's pretty much what we've had to do. Ken alluded to amikacin, and that's what I'm going to talk about. It has received increasing use over the past almost 10 years, I think, as a potential medicine for NTM. Amikacin is good for most NTM, but when given systemically, is potentially very toxic, as most of you know. Can affect your hearing, can affect your kidneys. And so we're very reluctant to give it very long and rarely can give it long enough to produce a benefit, especially for diseases like Mycobacterium abscessus, where you have to give the medicine literally every day. Ken alluded to the clinical trial, which is ongoing for ARIKAYCE, but I would tell you that inhaled amikacin using standard amikacin, which we use for intravenous administration, that same material is inhaled by a nebulizer, and I suppose the first people who did it said a prayer that they would be able to tolerate it. It's not great, it's very difficult to tolerate, but it's a lot easier than giving the medicines intravenously. Like the other drugs, we have no susceptibility methods for MAC. So Ken and the company are kind of, so we're doing a trial of a drug, but we don't even know whether the particular isolate we're looking at should have or should be susceptible to amikacin. We have no number values that tell you that.